Everyone, so now we are going to do this one, quality of service component and the policy for wire and the wireless. So this quality service is same as we done in CCNA level also. We will have some lab here and some theory. So quality of service, what is quality of service? Just we need to remember, quality of service is a feature of router and switch which prioritize the traffic. We have one feature available on the router and switch which can prioritize the traffic on the router. Generally, if you see here, let me take here, imagine you have one router here. Okay, you have router R1, you have here input and this is output. This is going inside the router, this is coming outside the router. Whatever traffic router will receive, he will process and he will forward. By default, router don't know anything about the traffic. He don't know anything which traffic is high important, which traffic is low important. Router don't know anything about that one. Even switch also don't know anything about that one. Just whatever frame switch will receive, he will process and he will forward. He will do first in, first out. Whoever come first, he will process first and he will send out first. Means router don't know anything about the priority. Switch also don't know anything about the priority. Priority means giving the important to the traffic. Maybe we can say, example, in your office, if anyone is coming, you will give the, if your manager came, you will give you the first priority. Instead of if you are talking with your colleague or you are working with your colleague, if suddenly your manager came, you will give the high priority to the manager. You will listen to manager, you will stop whatever you are doing, so you will give the high priority. But here router will not do anything or switch will not do anything. Generally, quality of service we will apply on the firewall. Generally, in the real scenario, we will apply this quality of service in the firewall. But by default, firewall, router, switch, they will not do any quality of service. We need to enable, we need to tell that router, this traffic is important. Whenever this guy will come, stop other guys and process this guy. We need to tell to router, we need to tell to switch, we need to tell to firewall, because they don't know anything. So what we are saying, quality of service is nothing but giving the priority to the traffic. Giving the priority to the traffic. We have the feature in the router, switch and firewall that we can prioritize the traffic. We can give the higher priority, lower priority to the traffic. How we can do? We will check that one. We will do one lab. You will have the idea that one. So now what we need to remember? We need to remember QoS is nothing but quality of service. And this is a feature available on the router and switch with which what we can do, we can prioritize the traffic. What is important traffic, we can process first that one compared to other traffic. So quality of service allow us to queue, limit, filter and mark reservation for our network traffic. Network device does not really care about the type of traffic they have to be forward. Router, switch, firewall, whatever they receive, they will check the routing table, or if you are using the switch, he will check the MAC table and they will process depending upon the MAC table on the routing table. They don't know anything about the priority, just they will process and they will forward. But what we need to do, we need to give some priority. Example, if you take the router, he will receive whatever packet he receive, he will look the routing table and he will forward that one depending upon that interface. Router, switch, they will not do anything by default. So we need to tell to router that this is important. This is first need to prioritize this one. So if you see this scenario, in this scenario what we can say, here we have the one PC, one host, and here is the host 2. We have some IP phone here. So traffic V is going in this direction. This guy is sending some traffic from here to here, this machine. And this guy is also sending some voice packet. He is also calling from this guy to this guy. So this data packet, voice packets are going in the order. They don't have any priority, just they are going in the order. They will forward here. Whoever come first, that guy will leave first. That's all, without priority. But we need to do the priority. But if you think why we need to give priority, what is the use? Before we are not doing the quality of service in the olden days. So if you see this scenario, this is a olden day scenario, like traditional network. In the olden days, in the traditional network, what we are doing, imagine this is your head office, this is your branch office. This is your head office, this is your branch office. If you want to use the landline, you are using the PABX, public switch telephone network. We are using the PABX. With that one we are connecting the landline, and if we want to make the video call or voice call, we are using ISDN. In the olden days, in the traditional network, we are using this one. So this guy want to do any video calling, for the business video calling, they will use this ISDN line, and for the server we will use only IP WAN connectivity. This is in the traditional network. So we don't have any issue because we have different dedicated line. For the IP phone, for the telephone line, we have separate dedicated line here. For the video conference, we have separate dedicated line here. For the data, we have separate dedicated line here. So no need to worry, we will not have any load here in the traditional network, olden days. But now in the new network, what we have nowadays, we are using the IP phone, and we have the IP WAN connectivity. If you are using IP phone, that traffic also going through the IP WAN connectivity. If you are doing the voice call, video conference, business video conference, that is also going through IP WAN connectivity. If your office is having some server, any data is uploading, downloading, anything, that is also going through IP WAN connectivity. So now we have the load. We have the more load on the IP WAN connectivity compared to the traditional one. Traditional one is having a dedicated line for each and individual guys. Means like IP phone is having separate line, we will have the video conference is having separate line, and the data server is having the separate line. But now we have only one line. All guys are using one line. IP phone is using one line, and the video conference is using one line, and the data also using one line. So here we have the load. We have increased load. Load is increased here. If we are using normal telephone, that will go through PSTN, okay, public switch telephone network. But if we are using IP, then it will go through IP WAN connectivity, and video call IP WAN connectivity, any data IP WAN connectivity. So our load is increased here in the IP WAN connectivity. So for that purpose, we need to prioritize our traffic. If we did not prioritize our traffic, we will have the losses. To overcome these types of losses, we need to do the quality of service. We have two things how we can overcome these types of solution problem. If you see here, we have the issue here. What issue we will have? We will have more load here, we will have the congestion here, more traffic here. So some traffic may be drop, maybe voice call is dropping, video conference is having some video is not clear. We will have these types of issue in the real scenario. So how we can overcome? We can have two solutions. One solution will be increase the bandwidth, but it will cost you money. You can ask the service provider, give me the more bandwidth, increase the speed of my internet connection, but you need to pay money. And the another technique is use the quality of service. With that one, you can prioritize the traffic. You can say, if anyone is sitting in the office and watching the YouTube, that guy should not get the high speed. If anyone is using the IP phone, that IP phone should get the high speed. And if anyone is using the video conference, that video conference should get the high speed. Not the other guy, whoever is using Facebook, WhatsApp or any other thing, that guy should get the medium bandwidth. We can prioritize. We can say data low bandwidth. Like that we can do. So with the help of quality of service, we can reduce the latency, jitter, losses of the particular traffic. What is latency, what is jitter, we are going to see now. So what we will have? We will have the solution. What is solution? We have two solutions. When we have the problem in our network, we have two solutions. We can ask the ISP. ISP means service provider, internet service provider. Increase my internet speed, increase the bandwidth of my internet. This is the one solution. This will cost you money. Or another solution, quality of service. So we can do the quality of service to get that one. So when we do the quality of service, we will select the traffic, and depending upon the traffic, we can mark this is a high priority, and we will tell to router this traffic if you receive, prioritize this one and process this first, and put the other traffic in the queue. Like that we can do. So how we can do? If you see, this is a IPv4 header. IP, that is Internet Protocol version 4 header. This is a IPv4 header. If you see in the IPv4 header, we have one section, type of service. In this one we will perform the quality of service. Here we will play something, so we can increase or decrease the priority of the packet here by changing the parameter in this section. So just remember IPv4 header is having the type of service. In this one we can play to change the priority of the packet. So before going to that one, now we need to have some terms, we need to have the idea. So first of all, what is bandwidth, and then congestion means what, delay means what. We need to have this idea before doing one basic lab. So what we can say, network bandwidth refer to the speed of the link or the interface in bit per second. Generally what we can say, bandwidth is nothing but, if you have one router here, what is this interface, fast Ethernet 0x0, so what is the speed of this one, that is nothing but bandwidth. The link speed or the interface speed, we can say bandwidth. Think bandwidth as a speed, that means capacity of the link. Network bandwidth is measured in the bits transmit per second. Congestion means in the network we will have more traffic, we will say congestion. If you have the more traffic on the interface, our interface will drop some traffic, that is nothing but congestion. So congestion will cause delay or latency. Latency, delay both are same, that is nothing but delay, means it will delay the traffic. Delay means delay or latency both are refer to a time it is taking for the packet travel from the source to destination. Example, if any packet, you have this router and you have another router, this is a source and this is a destination. If any packet is going from here to here, that much time is that one, the time which is taking to move from here to here, it is known as delay. So we can say delay or latency refer to time it takes for the packet to travel from the source to destination. In quality of service we have two types of delay, we can say fixed delay or variable delay. Another one is a variable, means when we want to go from source to destination, the time, whatever time it is taking, that is known as delay. The time taken to move the packet from the source to destination, it is known as delay. Okay, the time taken to move the packets from source to destination is known as delay. We have two types of delay, we have fixed delay and we have one is the variable delay. Fixed delay means, example, if you are going to office daily, it will take you 30 minutes to go to office. Okay, it will take you 30 minutes to go to office, but sometime like weekend, when you go on the Friday or Saturday, you will not have any traffic and you will go maybe in 15 minutes. So that is varying, that is nothing but variation in delay is a, we have one delay, one is fixed delay, another is a variable delay. So variation in delay is known as jitter. We need to remember, if anyone is saying we have jitter, means we have the variation in the delay. It is not fixed, sometime it is taking 1 minute, sometime it is taking 2 minutes, sometimes some seconds, like that is nothing but variation in delay. Just remember, jitter is nothing but variation in delay. Delay means time taken to reach from the source to destination, and if it is in the delay in the variation, then we can say jitter. And then we have latency. Latency is also known as delay only. Latency is also known as delay only. And packet loss means whenever we do not apply any quality of service, if we have congestion on the interface, interface is going to drop that packet, that is nothing but packet loss. And voice. In the network, voice is very sensitive to delay or drop the packet. It make no sense and not possible to retransmit or resend the voice packet. Example, generally in the real scenario we will give more priority to the voice and the video, because these both are using the UDP, user datagram protocol, UDP. So UDP, that is user datagram protocol, just he will forward the traffic, he will not acknowledge, he will not do three-way handshake, just he will forward the traffic, you receive or not, just they will forward the traffic. So if we miss, we will not retransmit, because UDP is not retransmitting. And if you want to retransmit, it will not good. Like if you are talking with someone, you are saying hi, hello, how are you, I will come. If some packets drop, this sentence will change to some different meaning to other guy. So for that purpose, this will not retransmit, and we are using UDP. UDP protocol is not going to retransmit. So what we can say, voice and video are very sensitive in our network, so we need to give more priority to the voice and video, because if some packets are dropped, we cannot retransmit. For data, no issue. If you are sending email or if anyone is browsing the data or downloading something, no issue. It is using the TCP. TCP is doing the three-way handshake, and they are sending the acknowledgement. So if acknowledgement not received, it will send that packet again. So for data, no issue. Data easily we can have any delay, no issue. Automatically, if anything is missing, TCP will forward again that one. So no issue for the TCP for the data. But voice and video is very important. Voice and video is very important. So we need to give the high priority. So we are saying we need to give high priority. So how we will give? So first we will classify and we will mark. We will check this is a high priority and we will mark that traffic. So for router or switch, we can give the priority depending upon the way. So generally we will use like a class of service, that is a cause for layer 2 marking. If we want to mark on the switch, we will use the cause, quality of service, that is a cause class of service. Class of service we will use for layer 2 marking, means in the switch we will use this technique. And for the router we can use the DSCP, differentiated service code point. We will use this one for the layer 3, and we can use the access list also to mark the traffic. We can use the network based application recognition also. This is application, this one also we can use. So now we need to remember for layer 2 marking. For layer 2 marking, that is nothing but class of service. We have the 3-bit. We are using for the layer 2 marking. Layer 2 means the switch. For switch we will take the 802.1q frame header. In that one 3-bit we have for the quality of service. 3-bit means we can say 2 power 3. If you write 2 power 3, that is nothing but 2 into 2 into 2. This is 4, and again you 2, that is 8. 8 means 0 to 7. We can say 0 to 7. So we will get the value 0 to 7. So we have the value from 0 to 7 we can set. The default value will be 0. That is designed as a best effort. Okay, and we can say cos 6 and 7, this is a reserve value for the network use, like routing protocol or any network control traffic will use the 6 and 7. This is a high, means higher the number, more important the traffic. So this is a high 6 and 7. We have 0 to 7. So 6, 7 is reserved for the network traffic. So now you have 0 to 5. So 0 to 5 is there. So what we can say, IP phone making call. So signaling traffic. Signaling means when we are having the ringing, that will reserve as a cos 3, and when anyone is talking, that is reserved as a cos 5. So we can say we can give the cos 3 for the signaling wise, and when we are talking, that will be give as a cos 5. Hello. Let me check someone is unmute or okay. So this is the standard value. After that what we can do, we can go for the cos 3. Okay, we have the marking we have DSCP, differentiated service code point. So this technique we will use. In this one we are using the layer 3 header. This is we are doing in the router and the layer 3. So in the layer 3 we have the 6 bits. 6 bits means 2 power 6. So possible value 2 power 6. If we look 2 power 6, multiply 2 into 6 times like this, you will have the 64 possible values. So that value will start from 0 to 64. So 0 means best effort, means we did not do anything special service. By default we will have 0. But for IP phone we can give the value as a 24. 24 nothing but DSCP 24. So whenever we want to say DSCP 24 is nothing but CS3, we can say CS3 is nothing but DSCP 24. And if we want to give the payload, voice payload, that is 45, that is nothing but DSCP 45. DSCP 45 is also known as EF. So when we configure, we can configure as a EF, that is nothing but DSCP 45. So depending upon what value you want to assign, we can use. So there are some standard value also, like DSCP 26 is nothing but AF 31, and DSCP 34 is nothing but AF 41. We are using this one for the SD video, and we have some more we are using for the critical data also. We are using this one AF 31. So we have different value. So like we can use that one. Example, let me show you. This is a chart. This is standard value as per the design. So we can use this one. Example, if anyone is saying this is a DSCP value, okay, this is a DSCP value. Example, I am saying like when you have here if you see here, we will take this one. DHCP24 is nothing but CS3. If you see CS1, CS2 we have. So let me take this one, AF31. If we have AF31, this one AF31. Okay, this is a AF31, and if you see, this is a value DHCP, and this is a 26 hexadecimal value AF31. So let me see AF31, where we wrote AF31 is nothing but DHCP26. DHCP26 is nothing but AF31. So AF31 is DHCP26. So these values we have. Generally what we will do, we will set that value. We have different method to do that one. We can set that value. Example, we will do this lab. So with that one you will have the idea. So what we will do, we will take one server here, we will take one router here, we have one switch, we have one PC here, and now we want to do some quality of service here. This is basic lab just to show you quality of service. So how we can do? Let me show you the configuration. We will use the CLI method. If you want to use the CLI method, let me show you first of all this method here, the steps. After that I will do this lab. So if you see this method, modular quality of service CLI. So this method we will use to configure the quality of service. So what we will do here in this one, we will use the class map, we will use the policy map, we will use the service policy. So these three things we will use. So what we will do when we use this one class map, when we use the class map, what we will do here, we will define the traffic to perform the action on it. So we will select the traffic, and here we will apply the action whatever we want to do the action, and then we will apply this in the interface. So we will use these three things to do that operation, in the router or wherever you want to apply. Example, if I want to set some condition on the router, so I will say class map. With this class map I will select the traffic. With the policy map I will apply the action, whatever action I want to apply. Then at interface I will apply the service policy. So when I apply the service policy, that action will take on that interface. So let me show you. If we do one lab, you will have the idea. So let me show you that one. We can do in the packet tracer. So let me take here, let me remove this. I will delete this one, or let me stop this recording, else it will become lengthy. So in next recording we will do the lab.